Alright, hello everybody. I'm sorry that I couldn't be with you today, but Mr. Tucker is going to be here with you today. So if you have any questions or anything of that nature, please make sure that you ask him. So throughout my video today, you're going to have to be pausing momentarily here and there, just so that you can finish copying notes or anything that you need to do in terms of that. So there should be a student that can help out in each of the classes. So if you could please come on up and sit at the computer so that you're able to pause as needed. And Mr. Tucker is going to be walking around making sure that you guys are copying your notes that we go over today. So we do have an objective today. You do need to get out your warm-up sheets that you have, and don't forget on Friday I'm going to be collecting these. Your mastery objective today is to use confidence intervals to estimate the difference in proportion of two populations, which is the beginning of Unit 9, our next unit. You do have a homework assignment tonight in your textbook, which will be over the notes that we do today. That's on page 508, number 4, 6, and 8. So what I want you to do for your warm-up, Mr. Tucker should be passing out some packets to you. These are going to be your packets for Unit 9 on inferencing for two proportions. What I'd just like you to do is go through the first page of your packet and take about 4 or 5 minutes and read through that and see if you can answer those first 4 questions on the front of that packet. So go ahead and pause your video now. Alright, so we're going to go ahead and move on. Let's talk about the first page of your packets that you already had the chance to read through. So in our last unit, we looked at one proportion confidence intervals and hypothesis tests. So just to kind of get you thinking, who do you think are more intelligent, men or women? According to a Gallup poll, 28% of men thought men were generally more intelligent, but only 14% of women agreed. Imagine that. Is there a gender gap in opinions about which sex is smarter? Can we use one proportion intervals and tests anymore? So in this case, we really are not able to anymore use the one proportion confidence intervals for an example like this, because we basically have two proportions here. One proportion of the men's opinion, and then the other proportion of the women's opinion. So we can't use that for this example. We can still use them, of course, but it's just not, these problems are not going to be using the one proportion. We're going to be learning about basically two proportion confidence intervals and two proportion hypothesis tests. Today we're just going to focus on the confidence intervals and go from there. So let's take a look at these inferencing techniques. I would like to estimate the difference in proportion of seniors and juniors that drive to school. Well, first of all, the word estimate here means that I'm looking at a confidence interval. Okay, so right away I can cross out my hypothesis testing because I'm not testing any claims here. Now, I have seniors and juniors. I have two basically proportions. So therefore I am using a two proportion confidence interval, which is what we're going to be talking about today. Here I'm going to test a claim. So whenever you see test a claim, you can get rid of a confidence interval and you know that you're doing a hypothesis test. And in here we're just looking at the claim that 60% of kids respect their parents. So in that case I'm just doing a one proportion hypothesis test because it's just one proportion that I'm looking at of kids that respect their parents. Again, test a claim, so I'm not looking at a confidence interval, I'm looking at a hypothesis test. But I'm looking at the claim that more Marylanders than Virginians visit the DC monuments. So I have two proportions here. I have proportions of Marylanders and I have proportions of Virginians. So therefore I'm looking at a two proportion hypothesis test. And then the last one, again here you see this word estimate, so you know you're looking at a confidence interval here. And I'm just looking at the proportion of females that regularly paint their fingernails, so again you're looking at a one proportion confidence interval. Okay, so that's just a way, one way that you can look at the two different types of one proportion versus two proportion types of tests. And again, these are all inferencing techniques. Hypothesis testing and confidence intervals are both inferencing techniques. Alright, we're going to start now the process of two proportion confidence intervals. First of all, you're going to notice there are some common things that you will see. There are things that you aren't used to seeing because in all of these we are looking at the difference in population. So therefore, I'm going to use first of all my estimate of the difference, P1 minus P2. Okay. Then you are looking at the critical value again, which is your z-score from the confidence interval you're given. Remember, divide it in half, add to 50, that's going to be what you do an inverse norm on. And then in order to find your standard error here, which that notation should look familiar, the standard error, we are going to still do the proportion P1. We're still going to do the 1 minus P1 over n, but we have to do it for the population 1, and we have to do it for the population 2. And then add them together and take the square root. My conditions are still the same. I have to have a simple random sample, but I have to have it for both population. I have to have independent samples, but again for both population. My population size has to be bigger than 10n for both populations. And yes, for both populations, you have to do n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. So here's your first population and your second population. It is important that you identify your first and second population, so your population 1 and your population 2, and that's what you're going to do for the first step. We are using the same templates that we did from Unit 8. Those have not changed as far as confidence intervals are concerned or hypothesis testing. It's just that the process is going to be just a little bit different. Okay, so keep in mind that this is all you're going to get on your exams and quizzes. We have not talked about mean yet, so I have kind of blocked that out for now. But you are still going to get that same formula. Notice here it's statistic plus or minus critical value times the standard deviation of the statistic. When you're doing two proportions, you have to find the difference. And there, this formula should look familiar from the top of the page. And then, of course, this should look also familiar. Just the wording is going to be a little bit different for two proportions. Okay? All right. So let's go ahead and move on to our first example. So you need to get ready to write. In our first example, we're looking at, suppose I would like to know the difference between the proportion of male and female teenage drivers that have been in an accident with 99% confidence. So again, I'm looking for the difference in proportions, okay, of male and female teenage drivers. To estimate this, I take a simple random sample of 50 male drivers and find 34 of them, and take a simple random sample of 45 female drivers and find the 29 of them. Based on the sampling, what can you say with 99% confidence? Alright, so you're going to want to pause this along the way, and I will kind of tell you when to pause it because I want to make sure that you get this. So step 1, I want to find an interval that with 99% confidence will estimate the difference between the proportion of male. So here I'm identifying my P1 to be male, that's going to be my first proportion, and then my females are going to be my P2, which are my female drivers, and that have been in an accident. The parameter of interest is the difference in proportion of male and female teenage drivers that have been in an accident. So again, at any time, please pause this, or you can pull it back and rewind as needed. So now my conditions. Yes, I still need to make sure that my conditions are true for all of my, or for both of my different proportions. So step 2, my conditions are a simple random sample for both. That is given. Independent samples for both. It's safe to assume because they're both simple random sample. My population size is greater than 10n. And again, it's safe to assume that there are at least 500 teenage males and at least 450 teenage females. So I have to do it for both of them. Do your n times p and n times p minus 1 for both populations. And then again, you want to say, now I can use the normal model to create a two-proportion confidence interval. Okay, so please make sure you get all that down. Again, pause if you need it. Alright, step 3. That formula should look familiar from the first page of your packet that we talked about. Then I'm going to plug everything in. So again, my P1 here was my males, so my male proportion was 34 out of 50. My female proportion was 29 out of 45. My z-score from doing the center 99%, so that's 2.576. That hasn't changed. And then again, my P1 times 1 minus P1 over N1, and my P2 times 1 minus P2 over N2. You're going to want to simplify all that, and again, you can plug this in your calculator. They're just the same, and you should give the interval from negative 0.215 to 0.286. Now notice I have a negative percentage, which we haven't really seen before. We're going to talk more about that interpretation for tomorrow. For now, you just want to write that last step. I'm 99% confident that the difference in proportion of male and female teenage drivers that have been in an accident is between negative 21.5 and 28.6%. Okay, go ahead and just write this for now. We're going to talk more about this last part, if the interval was positive, positive, negative, negative, and negative, positive. Again, just go ahead and pause this and finish copying down these notes. Alright, in example 3, we're going to do very much the same way. Step 1, step 2. Again, step 1, you're just identifying what P1 and P2 is and stating the parameter of interest. Again, you want to verify all your conditions and then say, now I can use the normal model to create a 2-proportion confidence interval. In step 3, again, you're going to see the same formula. Plug in all your numbers in appropriate places, calculate your interval, and then state your conclusion. Okay, so go ahead and pause or rewind as you need to finish up taking these notes down for example 2. So what I want you to work on in class now is the next page of your packet, which is page 5. And in case you can't remember how to do it on your calculator, you're going to go to Stat Tests. You're going to go down to 2-proportion Z intervals. So again, you're going to do Stat, arrow over to Tests, arrow all the way down to the 2-proportion Z interval, and you're going to enter your X1 and N1, your X2 and N2, and then your confidence level. So if you want to check either of those examples that we just did, but right now I would like you working on page 5. If you don't have enough room, then please go on to another sheet of paper, but right now in class you need to have page 5 done. Tomorrow when I come back, I will be checking page 5 to make sure you have it complete. So work on it now so that you have somebody else to work with, and then your homework is the pages in your textbook that was on the prior screen that I just wrote. It is also at the bottom of page 4 in case you did not write it down. Okay, have a good rest of your day, guys, and if you have any questions, please come see me tomorrow morning. I will be back in the building.